for learning some of these commands and playing around with the operating system. I'm not sure how many of you have Linux instances available with you. Do any of you have any Linux operating system available where you can test it out, or where you can learn the commands, where you can learn? I mean, probably your laptops might have Windows in it, but it might also have a dual boot in it, which might have Linux or any sort of emulator or any sort of virtual machine running on your laptops. Anybody has this as part of your laptops or desktops that you have? Or don't worry, I mean, if you don't have, there is a quick way to kind of get your hands dirty with Linux. I'll get to that shortly. Okay, all right. So let's get started. So this module is on introduction to Linux and shell scripting. Maybe we may not be able to cover shell scripting today because it will be a little overboard for some of you. Rather, let's restrict today's session to only Linux, basics of Linux, how the file systems in Linux look like, and how do you run commands on Linux, right? And what are the basic commands that that you need to learn, as part of the ramp up. So the agenda looks like this, right? So what is introduction to Linux, and brief history about Linux and Linux file system, because that's very, very important to learn the basics of Linux file system and common Linux commands and demo. And also let's discuss a little bit in terms of what is tomorrow's plan and prerequisites that we will have to have in place so that, we can get started with shell scripting. I mean, any residual topics on Linux, plus we can get started with shell scripting from tomorrow. All right. So let's get started with, what is Linux? Like, Linux is basically an operating system, right? But most of you must be aware of what an operating system is all about, right? So where I'm sure, you would have had a subject in your engineering or graduation as to what an operating system is, right? But what are operating systems, right? So now, in order to um, before we dive deep into what an operating system is, in fact, operating system is the basis for everything, right? Basis for any software that is running, right? But what is software itself, right? How do you distinguish between software, hardware, application, database, and so on and so forth, right? What is software? Software is basically a collection of instructions that control the tasks that a computer performs. Okay. So in fact, computer, if you take a hardware, I mean, it's just a hardware at the end of the day, right? It has got a motherboard, it has got a CPU, it has got a RAM, it has got some peripheral devices, it has got an output device, it has got an input device, and so on and so forth, right? But at the end of the day, hardware alone doesn't make up the entire um, compute that we require, correct? So that's where you need software. So software is nothing but a collection of instructions that control the tasks that a computer performs. That where you have different types of software, right? And I mean, and each kind of software has got its own semantics, right? Are nothing but a set of rules that a software carries with itself, which it uses to interact with the underlying hardware. Okay. And also software can be changed without disassembling the computer and rewiring, right? Because at the end of the day, you store the software in a hard disk within the computer, right? And then you can replace that software with a new software, without disassembling the entire computer or rewiring the computer, rewiring the entire hardware underneath it, correct? So that's what is at a very bare minimum level what you need to know about what a software is. Okay, so now let's come to application, right? I mean, we keep hearing applications day in, day out, right? I mean, we install a lot of apps on our mobile devices, right? And we install a lot of apps on our desktop computers or laptop computers. So what is an application? In fact, an application is a software program that provides service for a computer user. Okay. While we know that software is something that can control the tasks a computer performs, whereas an application is slightly higher level. where an application is the one which basically allows an interface for users to interact with it. Correct. Let's take WhatsApp, right? WhatsApp is an application. WhatsApp has got a user interface. Skype has got a user interface. Facebook has got a user interface, right? Zoom, right? We are using Zoom right now. Zoom has got a user interface, right? And also, it cannot act without permission from the operating system. Okay, so now that's a layer on top of the operating system. It has to talk to the operating system. An operating system has to talk to the underlying hardware. Okay, that's the way it basically uh, interacts in a hierarchical fashion, right? It's like this, right? I mean, when you need an appointment with, say, a chief minister of a state, correct, or prime minister of the country, right? You cannot directly reach out to him, right? I mean, so you need you have certain departments underneath the chief minister, right? You'll have to go first, reach out to them. So then they talk to the respective executive secretaries, and then eventually, you get access to the chief minister, right? So it's like this. It's a kind of an hierarchical thing. So where you have an operating system in the bottommost layer, which is talking to the hardware, and then you have applications which are interacting with the operating system. Okay. So, so there are various different operating systems available, right? I mean, of course, all of us are aware of Windows, which is a very famous operating system, right? All of us use Windows day in, day out. We have Linux, right? The penguin symbol that you see is basically is a symbol for Linux, right? And then you have Mac. Mac is an operating system by Apple. Okay, so we have Mac OS, right, which is used for the Mac uh, MacBooks and also the Mac desktops. Right. Similarly, there are various flavors of Mac which is available. Right. I mean, you use it in your iPhones, you use it in your Apple Watches, and so on and so forth. The example of Linux is the flavor of Linux is Android. Android is nothing but Linux at its core. It's a very lightweight Linux at its core, right? And Android, you carry Android on your mobile devices, right? And similarly, there are also Windows operating system, various flavors of operating systems available, which power the desktops, laptops, or even mobile phones for that matter. But the crux of it is all computers, I mean, need an operating system to run. Without operating system, pretty much the hardware that you have is useless. You won't be able to do anything with the hardware without an operating system installed in it. So what is Linux, right? Linux, it's an operating system, right? As I said, you have at the bottommost layer hardware. Above hardware sits your operating system. Above operating system sits your application, and above application sits your user interfaces. Okay, so that's how it works. I mean, you can't take the operating system out, and you can't take the um, you can take the operating system out and have application directly interact with hardware. That is not possible, right? And some of the you might be wondering, what is an operating system and what are the common features of the operating system, right? In terms of what it provides. So basically, what it provides is it does so many things. I mean, in fact, as I said, that is operating system is the one which orchestrates and which acts as the interface layer between applications and hardware, right? So from that perspective, it does so many things. But to just name a few, it does the process management. When I say process, when you have a computer running and you will have multiple different softwares installed in it and running, so each process, each software would have process in it. Just a second, give me a second. Yeah, and you will have a lot of processes running within the within the operating system, right? And each is considered as a process which has got some memory space allocated to it, and which performs a certain function within the operating system, right? So that entire process is managed using the operating system, right? And there's something called interrupts. I'll not go too deep into this. I don't want to make this an operating system lecture. I want to quickly get to the subject, what we want, what I intend to do, right? So that we basically get on track with our core subject of learning AWS. But I'm just giving you a very brief and high level information on some of these, right? And maybe I'm sure most of you would have read all of this in your colleges. For those who are not from computer science background, you could just go look at. I can give you some links where you can learn the basics of what an operating system does. But again, that is not by itself very relevant and important. I mean, it's good to know, but it's not a must thing that you should be very well aware of it, right? So similarly, interrupts are something that are commands that are sent to the operating system, right, to the processor, right? All that is managed by operating system. Memory management, right? So we have got memory as attached to the attached to the computer, such as 8 GB, 16 GB, 4 GB memory, right? So now each program would store its transient data in the memory and temporary data into the memory, right? So all of that is basically managed by the operating system. File system, right? You have a hard drive attached to your computer. Okay, and the hard drive should be readable by your applications, by your programs, right? So now what operating system does is it has something called a file system, which it uses to manage the underlying storage associated with the computer. Device drivers, right? I've got a mouse attached to my computer, I've got a keyboard attached to my computer, I've got a webcam attached to my computer. So all of that, you need drivers which can basically manage the way the device functions, right? So that device drivers are managed by operating system. Networking, very important, right? I mean, without connecting to the network, your computer is pretty much, it's a dumb terminal, right? Off late, every device is connected to the network, right? So now network, it needs to have a ability to connect to the network either through a LAN interface or through a Wi-Fi interface, right? So all of that is managed by operating system, and also TCP/IP, right? I mean, I'm sure all of you would know what a TCP/IP means. So TCP/IP is transmission control protocol, internet protocol. Okay, so now TCP/IP is the heart of any networking that happens in the world today. Okay, so now that is the standard protocol that is used for interoperability between various devices, between computers, between networks, between mobile phones, and so on and so forth, right? So now it's very important that you learn also TCP/IP. I mean, if you are not aware of what TCP/IP is, it's important you learn TCP/IP. I can give you some links to it. I'm sure uh, students from computer science background knows what are the 7 layers of TCP/IP. Would somebody want to take a shot at it and tell me what are the 7 layers of TCP/IP?
Hello.
Yeah.
7 layer of TCP/IP.
Correct. Oh, it's called OSI.
Yes, sir. Presentation layer, application layer, session layer, data link layer, network layer.
Sorry. Go a little slow. Go a little slow. Presentation layer. What is the second layer?
Presentation layer, data link layer.
Okay.
Network
Third.
layer.
Okay. Fourth.
Transport layer. Session layer. Physical session layer, physical layer or application layer.
Oh, everything is correct except the sixth one. What is the sixth layer?
7 layers.
No.
Presentation
All the
layer,
layers.
application layer.
It is presentation layer. Yes, it is presentation.
Yes, sir.
Right. So now
Yes,
that
sir.
is the core of TCP/IP, correct? So TCP/IP spans across these 7 layers, right? And that is the standard protocol that is used by networks. And in AWS, you will need to understand the 7 layers of TCP/IP very well, right? So that when you work with AWS, and when you want to set up something on AWS, when you want to configure something on AWS, it is very important that you learn these 7 layers very well. Okay, I can give you links to some of those after this, right? And you can look up those links and learn. And maybe I would also request uh, students from say computer science background who are well versed with TCP/IP operating systems to sit with your friends who are not from the computer science background. Excuse me, who are not from the computer science background, who would need some help to basically understand some of these concepts. Maybe you can spend some time with them offline, maybe later part of the day, later in the evening, or any time. Maybe you can sit with them and help them understand this, and that way you can actually help your friends to come up to speed on some of those, and everybody will be on the same page. Okay. And security is another aspect of operating system, right? Because operating system is the one which provides the the right levels of security from protecting the process that is running, right? So for example, I'm running a Java process in my application, sorry, in my system. So now, if I have a virus in my in my computer, and if that virus is able to go into the Java process and it's able to basically read all the data from the Java process and send it to a remote computer on the internet, then my whole data is compromised, correct? And I'll be leaking my data. So it is at the operating system layer, there is a protection that is given at a memory level and at a process level. Again, as I said, input output, IO usually stands for output. Input output is where the entire input output streams are managed by the operating system. Okay, so this is a very high level, maybe 30,000 feet view of what operating system means, right? As I said, a lot of you must be aware of much more details of operating system, because there is a separate paper on operating system in your colleges. Okay, but for those who are not from computer science background, this is at a very high level. You understand that this is what an operating system does, right? So this is what a Windows does, this is what a Linux does, this is what a Mac OS does, right? This is what a Unix does. Okay, so now so having said that, let's get into what are the functions of operating system. We spoke about that, where it initializes the computer hardware, right? When you turn on the computer.
Hello, sir.
Hello. Yeah.
Hello.
Yeah.
Hello, sir. Yes, sir. Interrupts. So, how does the operating system help in interrupts, sir? I couldn't get that.
So let's do
Interrupts.
one thing. Okay, so as I said, interrupts are used in the context of CPU, right? So where if the microprocessor needs to perform a certain activity or prioritize on certain things, it is the operating system which actually sends the message to the microprocessor in the form of an interrupt, and the microprocessor receives that signal and then performs that activity, right? So this is to prioritize on the processes that are running, the softwares that are running on your operating system. Okay, that's where the interrupts help. But having said that, I mean, let's not get too deep dive into some of these, right? So because as I said, this is not an operating system session. The thing is, I want to jump into the Linux, right? I mean, you can go learn about some of these. I mean, there are a ton of videos available in YouTube, and there's a lot of interesting examples like semaphores, interrupts that are there as part of operating systems, which you can learn at leisure on your personal interest. Uh, uh, maybe right now let us focus more on getting into the core subject of what is Linux and how do we actually deal with Linux, because that is the foundation for learning AWS. Okay.
Okay, sir.
All right. And that way, I would actually request that you restrict your questions as well to something which is relevant in the context of this. I mean, having said that, I mean, don't hesitate to ask any question. I can point you to the right direction if you want to read more on some of those aspects, and you may want to do it on your personal interest. Okay, what are the functions of operating system? It initializes the computer hardware. What I was saying was, when you turn on your computer, it is the operating system which comes up first, right? So it then it initializes all the hardware in the in your computer, such as your mouse, your keyboard, your monitor, and everything gets initialized through the operating system, and then it allocates system resources to programs such as giving the right amount of CPU to your programs that are running, it's right amount of memory to your programs that are running, in such a way that it balances everything, right? Uh, it is like probably I would say um, like a impartial mother who's feeding their children, correct? So that's the way it does. It allocates system resources to all the programs, and then also it keeps track of multiple programs running at the same time, right? Where it has a lot of um, applications running at the same time, right? So it ensures that it keeps track of every program that is running, and then it ensures that it monitors the health of it, and then in case if it crashes, it again tries to bring it back. And then also it provides an organized method for all programs to use the system devices, right? For example, right now I'm on Zoom, right? I'm using the mic of the laptop that I'm currently connected from, right? So similarly, also I might as well later move to say Microsoft Teams, or I might move to Skype. So it is the same interface which is being used, right? The mic which is being used or speaker which is being used. So the operating system provides a very organized method for all programs to use all the system devices. Okay, a little bit history of Linux, right? Before Linux was invented, right, in the 80s, Microsoft DOS, disk operating system it's called, was the dominated OS for PC, right? In those days, if you go for any personal computer, you had DOS running in that, right? DOS is again it's a terminal based, it's a operating system, which was created by Microsoft, and DOS was the dominant operating system. Later on, Windows came. Windows was also based on DOS to a certain point in time. So then Apple came up. Apple invented their Mac. Steve Jobs invented Mac operating system. Macintosh, it's called Mac operating system. Apple's Mac was much better, but it was quite expensive. So then came Unix, right? Unix was also much better, but much more expensive. Only for a mini computer for commercial applications, Unix was being used, right? And to buy a Unix license, it would cost tons of money. But Unix was quite efficient, and Unix had a lot of features in it, and Unix was very fast, and Unix was very efficient in handling the system resources. Because I said in the last slide that managing the system resources is one of the key functions of operating system, right? It has to efficiently manage to uh, allocate CPU and memory to the applications or softwares that are running in the operating system, like an impartial mother, correct? So Unix was very good in doing that, but again, it was not quite cost effective, and people were actually looking at a Unix-based system which is cheaper and which can run on a PCA, right? And that's what people were looking at. That was the ask that a lot of people in the industry had. That I need a cheaper operating system which is as good and efficient as Unix and which can run on my personal computer. Okay, but on the flip side of things, DOS, Microsoft's DOS, Apple's Mac, and Unix, all these were proprietary, because the source code, the source code that powers this operating system, were all protected, and it was all proprietary, right? And nobody had access to the source code where they could take the source code and write their own operating systems based on that. That is not possible because these are all proprietary, right? Because at the end of the day, these are intellectual property, right? So it was not possible, and no modification is possible without paying high license fees, right? I mean, if you buy a Unix or DOS or Mac, I mean, you have to pay a very high license fees to their parent companies. So then Linux arrived. So inspired by the Unix operating system, the Linux kernel was basically developed as a clone of Unix, as a very similar of how Unix is built. Similarly, Linux was built on similar lines, and it was started in 1984 by GNU. with a mission to develop a free Unix-like operating system. They wanted to make it completely free, right? They don't want to charge. The source code is available. Anybody can take it. Anybody can modify it. Anybody can run it. Anybody can again again put it back on the internet for people to download and make use of it. Okay, and then when I say kernel, a kernel is nothing but, I mean, it's important to spend some time, 2 minutes, on what a kernel means. Kernel in an operating system is the core. Okay, the core of operating system. So that is called kernel. Okay, so kernel is where all the core functions such as managing the devices, right, interacting with the devices, and also all the low level functions that an operating system performs, such as reading and writing from the disk, reading and writing from the memory space, right? Memory, when I say memory, RAM, is all done by the kernel, right? So the kernel is the core, right? Anything surrounding the kernel are the peripheral systems, such as your other programs that are running in your operating, as part of your operating system. Okay, which anybody can build and anybody can modify and things like that. But kernel is the core of the entire operating system. Okay, so okay, it's like this, right? Let me give another example. You have a car. Okay, a car is being manufactured. When a car gets manufactured, what is the foundation for a car? Can somebody take a shot at it? On what a car is built?
Chassis.
An engine, sir.
Yeah, chassis. Okay, somebody said chassis. I heard that. Okay, of course, engine is needed. I'm not denying that, but chassis is the
Engine,
yeah. So
engine,
chassis is
all
the
accessories,
correct. So
all the
basically, if you
parts.
see, chassis is the one, which is which is very very important for a car, because that is where the rest of the rest of the parts of the car is actually built on, right? Once you have the chassis, so then on top of chassis you have a body, and you fit an engine to the car, you fix the wheels, you fix the steering, and you fix all the other components, clutch, accelerator, brake, and so on and so forth, right? So now look at the kernel as the chassis itself. Okay, so that is where the core of the car is chassis. Similarly, the core of an operating system is kernel. Okay, and then this Linux kernel was built, and it was basically passed on to so many interested developers throughout the internet, right? And Linux today is a result of efforts of Linus Torvalds. Okay, he is the individual gentleman who invented Linux and who wrote in Linux, who programmed Linux, and then he inspired so many other people to basically participate in that project. And later on, it became a very huge project. Okay, and then a lot of people, started following Linux, right? And lot of people across the globe, lot of contributors came in for Linux. A lot of them started building, programs for Linux, modifications to the Linux code, and then started releasing their own versions of Linux with a lot more advanced features, right? And so that's how, I mean, if you see, even a small device, right, today, these days, has got some sort of Linux kernel embedded in it, right? Like, let's take a washing machine, let's take a refrigerator, let's take a air conditioner, right? Some of these devices are also embedded with Linux today, right? So they have a small chip embedded which runs Linux, which controls the way the washing machine functions, the way the refrigerator functions. Even cars have got Linux in it. Okay, so now that's a very brief history about Linux. In fact, I can show you a few links towards the end of this, where you can download the entire Linux source code, some of the open source distributions of Linux, and it's open source. The best part of it is it's open source. What is meant by open source? Most of you are aware of. The source code of the software is available openly on the internet, publicly available. So anybody can download it. Anybody can download it and make use of it, or read it. And there are different licenses that govern the open source today. Okay, there are multiple different licenses that are available. Apache license is one common license. GNU GPL is another common license that is being used. Okay, you can read through some of these later on. So now Linux, if you see, like say CentOS, okay, CentOS is a popular, uh, you know, flavor of Linux. Ubuntu is another popular flavor of Linux, right? So they're all available as source code, right? In fact, I can show you right away. Okay, just Google for it. Um, just say CentOS source code download. Okay, so if you see here, just go to this wiki page. It will take you to yeah. If you go to this GitHub is another popular source code repository, right? So you see here, you'll see the source code here of entire CentOS available publicly, which you can go ahead and make use of. Okay, but the only thing that you'll have to be aware of, you need to read the licensing of this particular software so that you abide by the license. Sometimes it says that you can use the code, you can modify the code, but you cannot redistribute the code, right, for commercial purposes. Okay, where you can't build something out of it and make money out of it, right? So that's some of the restrictions that some licensing might have. Anyways, you can take a look at it. And as I said, it's basically a kernel that combined with various
Excuse me, sir.
softwares. Yep.
Sir, actually, Linux is also OS and Ubuntu is OS, sir. So,
Yes.
CentOS, all these are OS. So, these are comes under Linux, sir.
All comes under Linux. I'm just going to come there. Just give me a
Okay.
minute. You will see that,
Sure, sir.
what are the various flavors of Linux. Okay.
Okay.
Um, we saw that it is basically a kernel. It was combined with various softwares and compilers from GNU project to basically form a OS called Linux. So that's how the name Linux was arrived at. Okay. So in fact, if you recall, it's built by somebody named Linus Torvalds. Okay. So now Unix, he built Linux based on similar lines of Unix, correct? So what he did was he named Linux similar to what his first name is. His name is Linus. He took Unix and then he made it Linux. Okay. And then it's a full-fledged operating system available in the form of various distributions, right? So now what those distributions are, right? To answer your question, there are various flavors of Linux available, such as Red Hat, Fedora, CentOS, SUSE, Ubuntu, Debian, and so on and so forth. Okay. In fact, even Android is a flavor of Linux, which is a mobile operating system. Okay. And the best part is Linux is supported by big names such as Amazon, IBM, Google, Sun, Novell, Oracle, HP, Dell, even Microsoft has started supporting Linux of late. Okay. In fact, SQL Server can run on Linux, .NET can run on Linux. Earlier only .NET could be run on a Windows operating system, but now it can be run on Linux as well, right? So these are the various different flavors of Linux available, right? So when I say flavors, what they have done is they have taken the core kernel, which was built by, which was originally built by Linus Torvalds, and then later on contributed by thousands of developers across the globe. And then they took that core platform, and then they started uh, building on top of it. They started making some changes uh, to the platform. Okay, and then they basically rolled it out as their own version of Linux. Okay, so that's how so many versions of Linux came into existence, like Red Hat, Fedora, CentOS, SUSE, Ubuntu, Debian, and so on and so forth, right? And even now, a lot of people are actually working on releasing newer flavors of Linux because it's open source. The source code is available free of cost. Anybody can take it. Even if any of you are interested, you can take the source code, you can build your own version of Linux, and you can use it in your own devices that you're planning to build, like IoT, right? When you have IoT, you can use your own version of Linux instead of relying on any of these. I'm just throwing an idea. So now you may ask, okay, how many flavors of Linux are available? I mean, these are the most famous ones, right? Like Red Hat, Fedora, CentOS, SUSE, Ubuntu, and all. But how many other flavors are available? If you see, these are all the flavors of Linux that are available. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. About 50. I can see 50. I mean, again, this is not an exhaustive list. Okay, there could be a lot more which people must be using. Maybe they are not publicizing those. But if you see, these are all the various different flavors of Linux that are available, right? As so many distributions. The most common or the popular ones are Red Hat, Fedora, Debian, CentOS, Ubuntu, somewhere CentOS must be there. Yeah. So now, so that's what it is. So now I guess you can understand, the gravity of it, right? As to how popular Linux is and how important it is for you guys to learn Linux, or at least know how to interact with Linux, right? So that you basically, because you go to any organization, any enterprise, they must be running both the major operating systems in their footprint, right, as part of their infrastructure footprint, both Windows and Linux. So it's
Sir,
important, you
excuse me,
learn.
sir.
Yeah.
Yeah, so what will be the difference between Red Hat and Ubuntu? So among them,
So as I said, some additional features will be there in Red Hat. Some additional security enhancements will be there in Red Hat. Whereas in Ubuntu, if you see, I'm not saying that Ubuntu will not have it, but Ubuntu will have a little more features. So it's like, for example,
it's like version, sir.
say I'm no, they're not versions. They're different flavors altogether, right? So where uh, uh, I'll give you one simple example of difference between Red Hat and Ubuntu, right? So in Red Hat, if you have to install a software, uh, you have to use a command. In every Linux, you have to use a command to install any software. Commands are the ways to interact with Linux. Okay, while Linux have got GUI, but again, that GUI is okay and not used very popularly by people. It is basically, it gives you the flexibility to interact with the operating system using a command. Okay, for everything you type a command and you pass the command to the operating system, so that operating system can execute that command and give you the results. In Red Hat, if you have to install softwares, there's something called yum repository. There's a command called yum through which you install softwares. Whereas in Ubuntu, you use something called apt-get, apt-get. So these are some unique things that people have built on top of the kernel operating system. So that is what is the difference. So at the end of the day, you can use any of the flavors, any of the common famous flavors, which would fit your purpose. It's just that it's an individual's choice, and if I have worked with Red Hat for a long time, then I would go with Red Hat. If I know Ubuntu and I've worked with Ubuntu for a long time, I'll go with Ubuntu. That's it. That's the only difference.
Actually, sir, for Windows, we'll be having Windows 7, Windows 8, Windows 10 in that way. So for Linux,
Mm-hmm.
these are the different modifications. I'm thinking in
No,
that
these
way.
are not versions. As I said, these are not versions. These are flavors. Within each flavors, there will be multiple versions. Like for example, Red Hat is there, right? Red Hat Enterprise Linux 6 is there, 7 is there, 8 is there. So within each one of these, they'll have multiple versions of it. Whereas
So
Windows, there's
actually,
only one flavor of Windows.
Linux is also already an operating system. So in that, then these are the flavors. Means how could we compare with Windows, sir? In that way, I'm asking.
No, Windows is proprietary, right? Windows is built by one company called Microsoft, right?
Yes, sir.
So they have only one brand called Windows, and Windows is not open source. They don't give out the source code. But whereas in Linux, what they have done is a person initially started Linux, coded Linux, and then he gave the source code free to everybody. So everybody took that source code, they modified it as per their wish, and then they started creating their own flavors of Linux because source
Okay.
code is available.
Okay, sir.
But in Windows, that's not
Yes, sir.
possible. Even in Mac, that is not
Yes, sir.
possible because how will you modify the source code? You won't be able to modify the source code, right? Unless and until you have it. So that's how,
Okay,
if you
sir.
see, these are all the various different
So
flavors of
everybody
Linux that
different
have come
flavors.
up. Correct.
Yes, sir. Right now I get it, sir.
Okay. Okay. So now let's look at the file system within Linux, right? At the end of the day, as I said, Linux or any operating system will need to deal with the file system, right? What is file system? File system is the storage, the underlying storage, the hard disk that you have. In Windows, you have a C drive, D drive, E drive, right? And where in C drive you store all your system files, okay, program files, and so on and so forth. Windows directory is there in C drive. Similarly, in Linux also, file system is an important aspect, and you guys need to understand what a file system is, right? So in Linux, either Unix or Linux, it's a hierarchical directory structure. Okay, so where you have a hierarchy of what is hierarchy? Hierarchy is a tree-like structure where you have a parent folder. Under the parent folder, you have subfolders and so on and so forth, right? It's basically, it resembles an upside down tree. In fact, shortly there is a diagram. You will be able to understand it much better. And then directories or collections of files and other directories. Same as like how you have in Windows. The structure is recursive with many levels, right? When you say recursive, all of you would have, at least computer science students would have done recursive programs using C, C++, correct? How do you run a recursive? So that way, it's a recursive structure where you have a top directory, under that you have files, and you have subdirectories, and under that you'll have files, subdirectories, and it keeps going on and on. And every directory has a parent except for the root directory. In this case, root is the parent of everything. Okay, it's like the tree. Your tree has got roots, correct? Here, root is one parent directory. Under that parent directory, everything else is a subdirectory or subfiles. Many directories have child directories. Unlike Windows with multiple drives and multiple file systems, Linux has got only one file system. Okay, so that way, everything is managed within that one single file system in a very hierarchical fashion. Um, so again, you don't have to worry much about this LSB. I just thought of putting it. LSB is a Linux standard base specify the structure of a Linux file system. Okay, so now if you see, this is how the whole file system in Linux looks like, where you have a root which is represented as a forward slash. Okay, you have in your computers you have special characters, correct? Two special characters. One is the backward slash and the forward slash, right? So this is the forward slash. Okay, so now with this forward slash, you will be able to represent the root. Okay, under that you have bin, you have boot, you have etc, user, where, sbin, and so many other folders. Okay, they're all folders. Okay, and within those folders, you'll have various different files, or there can be multiple subfolders. Like under slash user, there is slash local. Under slash local, you will have slash bin. Right? I mean, these are all directory structure under the parent folder. So in this case, the parent root is the parent. Under root, you have all of these, and under these, you have further subdirectories. Under subdirectories, you may have files or again subdirectories. Okay, so this is how a file system is represented in Linux. Don't worry too much if you're not understanding it. When you do the lab session, you'll be able to get a sense of what we are talking about here. Okay, you'll be able to correlate to what I'm trying to say here. Okay, and also there are commands that you can execute in Linux. As I said, usually a Linux is a terminal based operating system. Okay, so where you have a terminal. When I say terminal, okay, so all of us have gone to book train tickets, correct, and reservation counters. Okay, in railway reservation counters, all of us would have gone to at least book tickets once in our lifetime, correct? Of late, we are doing it all online through IRCTC, but I'm sure all of us would have gone. So now the person who is actually booking the ticket, the agent who is booking the ticket, he or she will have a computer, and then they will have a black screen, and in that black screen they keep typing something, correct? Type all the details and enter the data that you provide. So now that is called a console or a terminal. Okay. So now similarly Linux also has got a terminal, right? So where you interact with Linux by through a set of commands that you execute on the operating system. Okay. Unlike Windows, where in Windows you have a or in the Mac you have a, I mean, I use a Mac. So in Mac you have uh, a graphical user interface, right? And use through this graphical user interface, you browse all the programs. So similarly, even in Windows, you have a graphical user interface, and using the graphical user interface, you go interact with the operating system. Okay, but Windows has also got a terminal. There's a command prompt in Windows, right? You open the command prompt, you can execute commands and things like that. But primarily in Linux, running a command on the terminal is the most common and most efficient way of interacting with the operating system. While Linux has got graphical user interface, I'll show that to you in a bit. You will be able to see that. And there are multiple commands that are available in Linux. Uh, One common command is man. Man means manual, right? Man is the one, which gives you the help, right? For example, in Windows, when you want to get some help, like say for example, I'm using a Mac, so I want to get some help on PowerPoint, which is installed. I just go here, I'll click on help and PowerPoint help, right? It gives me a pop-up which tells what I'm looking for. I can go ahead and read through this manual, correct? Whereas in Linux, what you can do is I'm just opening a terminal. It's a Linux terminal pretty much. Mac also uses the same style, right? I can say man curl. Right? Yeah, see, it gives me the text of what is curl. Curl is a command that you use in Linux, right? It tells me what is the um, I mean, what is the what is the instructions of using curl, and what is the manual of this using this, and it gives me various different options. Okay, so that way you interact with Linux using a set of commands that you have. Okay, and then little more on the file system of Linux itself. If you see, this is how the file system of Linux is hierarchically structured, right? So where you have the hardware underlying, you have device drivers, and you have the file system. This file system is nothing but your disk, the hard disk, and then you have the Linux kernel, which is interacting with the file system. On top of it, you have shell, right? Shell is nothing but this is this is the shell of Linux. Okay, where you get the terminal, right? Usually the terminal is called the shell. Okay, you'll have to get used to some of these terminologies, because you will come across this every now and then, right? Shell, what is a shell? Shell is the terminal of Linux through which you interact and you pass commands. Okay, and then on top of shell you have the user command, where you send a user command, it talks to the shell sends it to kernel, kernel manages the resources to file systems, and then it talks to the hardware. Okay, so now, as I said, this is the hierarchical um, directory structure, where you have slash is the root. Under that you have various different subdirectories. Under that you have further subdirectories, and you will have files as part of the subdirectories, right? So now the way you store the files are in a hierarchical fashion. Okay, single rooted hierarchical fashion it is called. Data files are stored in directories or folders. The actual files are stored in directories or folders, and directories may be nested as deep as needed. Okay, so that's how, if you see, these are all the directories, and this is the data file, right? The data file usually is stored in the leaf node. Okay, under data files there won't be anything. So yeah, all of you are aware of binary tree, right? B tree structure or tree structure, correct? Where you have nodes and leaf nodes, right? So leaf node is the end, right? Let's take a tree. Okay, so tree has got a big trunk. Trunk has got several branches. Branches have got several twigs, and each twig has got several leaves in it, correct? and leaves and flowers in it, correct? But beyond leaf, there's nothing, correct? Leaf is the end. After leaf, there is nothing that is there, right? So that way, here also, if you see, leaf nodes are the actual data files that are stored in the directories. So now in this case, let's take an example. How you represent files and how you refer to files that are stored in the Linux operating system. Okay, so now let's say there is a file called password which is stored, or a file called A and B which is stored under a folder called Neil and home. Okay, so now how you refer to the file called B? You have to start from the top. Okay, because you have to start from the root. Root is slash, under slash you have etc home and user. So you want to basically look at a file which is present in the home directory. So then you say home slash home. Under home you have Neil, Scully and Marty, right? But you want to look at the file which is under Neil. Okay, so now then you say slash Neil, then you say slash B. Very simple. Slash home slash Neil slash B. Okay, that is how you look up this file which is present in the hierarchical uh, convention, right? And then you basically either you copy this file, delete this file, or read this file, or do whatever you want with this, right? But this is how it gets represented. Always remember, slash is the root. Under that you have directories. Under directories you have subdirectories. Under subdirectories you have further subdirectories, or you have files, and you have it can keep going on and on in a very recursive hierarchical fashion. Okay, so any doubts in this structure? Just remember that this is the convention, and this is how you look up files, and this is how you deal with files in the Linux file system. Because this is very important, because you might want to basically get a grip on this, so that you do any programming or you do any shell scripting. This is the fundamentals for learning those.
I
Okay,
couldn't get that. What below under the home, sir? Neely, Scully, and Marty. Neely.
these are folders,
What is
that's
that?
it. These are folders. Just
Okay, sir.
name, some name.
Okay, sir.
Okay. These are just name, some name. Okay, probably I'll change it to Ravi, Praveen, Prasanna, things like that. Okay. It's just the name, that's it. It can be anything. It can be folder A, folder B, folder C, file A, file B. I'm just showing an example here, that's it.
Okay, sir.
Okay. Okay, all right. And then the current directory, right? I mean, if you see, if you're currently in the folder called Neil, okay, that becomes your current directory, and then you can run commands on that current directory to basically list all the files and folders that are present in this directory. Okay, so now one directory is designated the current working directory. If you omit the leading, then path name is relative to the current working directory. Okay, and you can use a command called pwd. Pwd means present working directory. If you want to know which directory or which folder you are there, you can use pwd to find where you are. Okay, it's similar to what you do in Linux, Windows also, right? In Windows also, you open File Explorer, you keep clicking, keep clicking, but you want to know which folder you are in, you look at the top address bar to see where you are, correct? But that has got a graphical user interface. But in Linux, you don't have a graphical user interface. You have to deal with all commands in Linux. Okay, so now I'll give you one more example. I mean, don't get too bogged down by this. When you do examples, when you do labs, you will be able to understand it much better. So if you see, uh, I'm right now in the nail directory. Okay, I've navigated myself there using a command, but under that I want to basically read letter. Okay, letter is another file that is there, and doc is a directory. Okay, so now under doc there is a file called letter. I want to read that letter. It's all relative from that particular path. Okay, that is the beauty of Linux, right? It is all relative. You don't have to give the absolute path every time, right? Slash home /nil/doc. If you are already in nil, you just say doc/letter, you'll be able to read the letter file. Okay, or you can use dot. Dot means the current directory. When you say dot, dot means wherever directory that you are there, that is the current directory. So now when you write shell scripts and when you execute shell scripts, it's very important you know this notations, because dot, okay, dot is the one which basically says that execute a file from that particular folder itself, right? And shell scripts, you will come across a lot of things where you will execute the shell script from that particular current folder, or you can also execute it with the full folder structure, /home/nil/doc/letter. So these are the three ways in which you can um, read the file called letter. Either it can be relative from here. If you're already in nil directory, it can be, you can just say doc/letter, or you can say dot means the current directory /doc/letter, or you can give the full path from right from /home/nil/doc/letter. Okay, remember these three things. We will do lab exercises. I'll show you how it works. Okay, and if you see, as I said, some of these are like special file names, right? Slash is the root directory always. Dot is the current directory. Double dot is the previous directory. Okay, and then tilde, you have tilde symbol, right? Tilde is your own home directory, the user who has logged in. There are multiple users, right? When you have Linux running, there can be multiple users that can be created in Linux operating system. A user can be created for Ramu, a user can be created for Chandru, a user can be created for Ravi, or user can be created for Deepak, correct? So now, there can be multiple users created. So now each user will have their own home directory, okay, where they can store their files, like how you have in your Google Docs and all, right? So where you have your own home directory where you can store your files, so something like that. So tilde means it takes you directly to your home directory pertaining to that particular user. Okay. So when you say dot/a, it means you are there in the directory, and you're basically referring to the file called A, file or folder called A. When you say dot means you're going one directory before. Okay, you're going one directory before, and you're saying dot/jane/x. So go up one level, then look in directory called Jane for file called X. Okay, so these are some examples that you can learn, and also these are some of the folders that are there in the Linux, right? So where /home is where all the users home directories are stored here. Okay, slash means root. Okay, home will be one folder. Under home you will have Ramu, Chandru, Ravi, Deepak, Krishna, and so on and so forth. Okay, Jyoti, and so on and so forth. So that's where you will have /home directory. /bin will be a directory where you have binaries. Bin means always binary. Remember, when you come across bin, it means they are binaries. What is binary? Binary is a program. Okay, where the program gets executed from there. Okay, again /user/bin is where some system commands will be stored there. Okay, again /sbin/user sbin, they're all used by sysadmins, where if system administrators would like to automate something, right? So they will actually use /sbin. They'll store something in /sbin, and then they'll basically use that program to execute from there. Okay. So then /etc is again, it stores all the configuration files, operating system level configuration, and so on and so forth, network configurations. /where is where a lot of logs are stored, right? I mean, you have a lot of programs running, operating system is running, everything gets logged, right? As text files. So all of those logs are stored in /where. /dev is where device files are stored, right? You have hard disks, and you have USB drives, you mount something, all of those are stored in /device. proc is where special system files are stored. Okay, don't worry too much about this. You will get familiarized with all of this as you uh, get more and more introduced to some of the other things. Okay, so now let's actually see how to execute commands. After this, I'll actually show you some examples, live examples, demo of how commands actually work. Okay, how do you execute command? Right, you have a terminal where you get a terminal and you get a prompt where it is waiting for the user to execute a command. Okay, it will be waiting. So once you type the command and hit enter, the command will get executed by the Linux operating system, and the Linux operating system processes that command and gives you the desired results. Okay, so now how you execute those commands? On the prompt, you type the command and say hit enter. Okay, so now what does the command itself comprise of? The commands comprises of three things in it. One is the command name itself. What is the command name? Then options. What options you want the command to execute with? Those are called the flags that you provide. Okay, there can be multiple options, right? So when you run man is the help command, correct? When you run man and read in the man, you will see a lot of these option flags that are there in the commands. So then you have arguments. Argument is nothing but you pass some argument to the command so that it knows the context of what you're trying to do. Okay, argument can be optional as well. Okay, so now remember, these are the three things that are required when you execute a command in Linux. One is the command name itself, then the option that will control the behavior of the command. Third thing is the argument, an optional argument that you may pass to the command so that you get the desired results that you want the command to execute. Okay, so now that is what this is the bare minimum basic of how a command works. Okay, so now what I'll do is I think we have dealt a lot of theory right now. Okay, what we can do is we can just do some quick lab and we can do some quick um, hands-on session, right? I'll show you how to work with Linux and how to deal with it. Okay, so now all of you have got a laptop or a desktop, correct, with an internet connection. Obviously internet connection is there, otherwise you won't be here, but all of you have got a laptop or desktop, correct? And you're not logging in from your mobile device.
Yes, sir. So we have set that expectations that no one should be logging in that with mobile. So most likely 99% I'm expecting everyone is on laptop or desktop.
Perfect. Thanks, Ravi. So if you have your laptops or desktops, what you can do is you can actually I will send you this link. Okay, I can give you this link. It's a small. I'm sure you all have a Firefox or Chrome browser, right? I mean, use either Firefox or Chrome, where you can. If you have Internet Explorer, I mean, don't use Internet Explorer. Use either Firefox or Chrome. You can install Firefox or Chrome on your laptops or desktops, right? Once you install that, I want you to install